Hello everybody, welcome to the live session by Infinity Learned by Sri Chaitanya. I am Misbah, your maths educator, and in this session we are going to do the Fundamental Theorem of Arithmetic, which is as per the syllabus of grade 10 Pushpavati. So first we'll be doing the Fundamental Theorem of Arithmetic and then questions on the basis of it, as well as questions on the basis of LCM and HCF and the relationship between HCF and LCM of two numbers. So let's start with it. Hello Shining Star Education, welcome to this session. So let's start with it. So this is the fundamental theorem of arithmetic, that every composite number can be expressed as the product of primes apart from the order in which the prime factors occur. So that is a very basic theorem in mathematics. Hi Varsha. So let us see that every composite number can be expressed as a product of primes. Hi Shubham, welcome to this session. Suppose you have got 18. What is the prime factorization of 18? That is 9 2s are 18, right? So it is 2 into 3 into 3. So as per the fundamental theorem of arithmetic, this factorization is unique. What does it mean? That in the prime factorization of 18, 2 will come one time and 3 will come two times. You cannot get any other prime factor in the prime factorization of 18. That is the uniqueness of the fundamental theorem of arithmetic, right? But the order can change. Order means the factors over here can be written like this, yes or no? If you want, the factors can be written like this, because you know that multiplication is commutative as well as associative. So the order of the prime factors can change, but the prime factors over here, they are unique. It means 2 will come one time and 3 will come two times. You cannot get any other prime factor. You can also not get it cannot happen that 2 will come two times or three times. It cannot happen that 3 will come one time or three times. That cannot happen. 2 will come one time and 3 will come two times. That is the uniqueness of the fundamental theorem of arithmetic. Hi Somaya, welcome to this session. So is the fundamental theorem of arithmetic clear to every student? Every composite number can be expressed as a product of primes apart from the order in which the prime factors occur. So you must know the statement of the fundamental theorem of arithmetic as well. Now it is not hard and fast that you will write exactly the same statement in the examination. You must know the meaning of it and you can write in your own words as well. Because many a times they ask like this as well in your examination, that state the fundamental theorem of arithmetic of 1 mark. I mean, that can happen. It has happened previously as well. Like they will ask the statement and then they will give a question on the basis of that, like of 2 marks, something like that. I hope it is clear to every student in this session. Now let us do a simple question on the basis of it. This type of question you must have seen in every book, right? For example, can the number 4 raised to the power n, n being a natural number, end with the digit 0? Give reasons. So it's a kind of theoretical question. Can it happen? Tell me. Can it happen that this will end with digit 0? Is it possible? So the answer to it is no, it cannot end with digit 0. Let us see that thing. It is very simple. For example, we have got 4 raised to the power n. So 4 can be written as 2 into 2 raised to the power n, right? So what does it mean? In the prime factorization of this number, you cannot get anything apart from 2. Only 2 is possible. Now, if a number is ending with digit 0, what does it mean? If a number is ending with digit 0, just an example, for example, 510, it is ending with digit 0. It means that 10 is there in the factorization of that number. 10 is there in the factorization. It means that in the prime factorization, at least 1, 2 and 1, 5 must be there. If a number is ending with 1, 0, it means that in the prime factorization of that number, at least 1 time 2 is there and 1 time 5 is there. But you see, in the prime factorization of this number, you can never get 5. I mean, that is happening as per the uniqueness of the fundamental theorem of arithmetic. Because you cannot get 5 in the prime factorization of 4. So you can say that this number 4 raised to the power n will never end with digit 0 as per the uniqueness of the fundamental theorem of arithmetic. Is this clear to every student in this session? This can never end with digit 0 You have to write in the answer. It's a kind of theoretical question that as per the uniqueness of the fundamental theorem of arithmetic, you cannot get the digit 5 in the prime factorization of 4. I hope it is clear. It's a very basic question. Now, one more small question I'm writing over here, that you have to prove, suppose I have got this thing, 35 into 2 plus 35. You have to prove that this is a composite number. 35 into 2 plus 35, you have to prove that it's a composite number. Composite number and prime number, is that clear? Prime number means a number having only 2 factors. For example, I'll write over here. For example, 2 is a prime number. It is having only 2 factors, that is 1 and the number itself. For example, 17 is a prime number because it is having only 2 factors, 1 and 17 itself. So any number having only 2 factors is a prime number, that is 1 and the number itself. So that is a prime number. But a composite number will have more than 2 factors. So the smallest composite number is 4. It is having 1 as a factor, 2 as a factor and 4 as a factor. For example, you can have 18. The factors of 18 are what? 1, 2, 3, 6, 9, 18. So a number having more than 2 factors is a composite number, correct? A number having more than 2 factors is a composite number. Now 1 is neither prime nor composite because it is having only 1 factor. 1 is neither prime nor composite because it's having only 1 factor. So Srishti, over here we have to prove that it's a composite number. It means you have to show that it is having more than 2 factors. No, but you have to show that it is having more than 2 factors. So instead of that, you can just take 35 as common just to simplify. Am I right? So this is basically 35 into 3. So you can easily see from here that it's having 1 as a factor, 3 as a factor, 35 as a factor. So, and more than it as well. So it is only, if you want to prove a number to be composite, you have to show that it is having more than 2 factors, and that is enough. You don't need to write all the factors of this number. That is not needed. You don't need to write all the factors of it. You have shown that it is having more than 2 factors. So therefore, this number is a composite number. Is it clear? You have shown easily that it is having more than 2 factors. So therefore, it's a composite number. That is it. You don't need to write, you don't need to note down all the factors of that number. I hope that is clear. Okay. Now, you have seen how to find the HCF and LCM. You know how to find the HCF and LCM. Can you find HCF and LCM of these 3 numbers over here? Using prime factorization method, can you find the HCF and LCM? Using prime factorization method, you have to find the HCF and LCM of this number. So let us do that. For that thing, we have to prime factorize these numbers first, and then we can find their HCF and LCM. So what is the first number over here? That is 6. So 6 is nothing but 2 into 3. Then you have got 72. 72 is what? That is, you can do its prime factorization. Basically, you can do it like this as well. That is very simple. That is right. So that is basically 2 cube, 8 9s are 72. Correct. 8 9s are 72. That is its prime factorization. Now, what about 120? 120 is nothing but 15 8s are 120, right? That is the prime factorization. Is that clear? You can write power 1 over here. That is the prime factorization of 120 over here. Now, what is HCF? HCF is the highest common factor, or sometimes you will see GCD, greatest common divisor. It is the same thing. HCF is the highest common factor, or the GCD, that is the greatest common divisor. So how will you find the HCF over here? The first thing is see the word common over here. Common. It means that if you are finding HCF, you have to write all the common factors. So common factors are 2 and 3. Common means which is there in all of them. Which is there in all of them. And then you have to take the lowest power of the common factor. So you see power of 2 is 3, 3 and 1. So the lowest power is 1. And the power of 3 is 1, 2, 1. So the lowest power is 1. So HCF over here is 6. That is correct, Joshita. HCF over here is 6. Is it clear? Now you have got LCM. That is called the least common multiple. LCM. So in LCM, you don't have to write the common factors only. Writing common factors is not there in case of LCM. You have to write all the prime factors involved in all the numbers. Whether it is common or not, you don't have to bother. You have to write all the prime factors involved. So what are the prime factors? 2, 3 and 5. These are the prime factors involved. And then you have to take the highest power of the prime factors. Right? Highest power of prime factor. So you see 1 and 3. So highest power of 2 is 3. Then 1 and 2. Highest power of 3 is 2. And then highest power of 5 is 1 only. So this is the LCM over here. So this is 8 9s are 72. 72 into 5 is 360. So the LCM over here is 360. Is it clear? Somaya, HCF is the highest common factor. Whether you say HCF or GCD, it is same thing. GCD is the greatest common divisor. So the moment you see the word common, what does it mean? It means you have to take the common factors only. It means the factors of each of the number which is common. So the common prime factor over here, they are 2 and 3 only. Yes or no? 2 and 3 are the common factors over here, Soumya, in all of the 3 numbers. And the moment you are saying that it is common, what is the meaning of common? Common means you have to take the smaller power, na? 1 is included in 3, right? Similarly, 1 is included in 2. You have to take the smallest power of each of the prime factors. So therefore, 1 and 3 you are taking, and HCF is 6 over here. Is it clear? Right. Now, 1 or 2 more things in HCF and LCM. See, HCF of any number of numbers, if you have got 2 numbers or 3 numbers or 5 numbers or 10 numbers, whatever it is, just think that logically. HCF is what? Factor. So factor of any number can never be greater than that number. Is it possible? For any number, the greatest factor is equal to the number itself. Am I right? For example, you have got 15. What are the factors of 15? 1, 3, 5 and 15. So can any factor of 15 greater than 15? It is not possible. We'll do that as well, Joshita. Any factor of any number can never be greater than that number because that is a factor. You got my point? So any factor of a number can never be greater than that factor. Therefore, if you are finding the HCF of, suppose over here we have got 3 numbers, you can have 4, 5, 100 numbers, no problem in that. So the value of the HCF of 3 numbers, the greatest possible value of the HCF of 3 numbers is equal to the smallest out of them. You got my point? For example, you have got these 3 numbers. So the greatest HCF can be equal to 6. Can it be greater than 6? Tell me, is it possible? You got my point or not? Suppose you have got 3 numbers, then HCF of them can never be greater than the smallest value. Is it possible? The moment you take HCF which is greater than any one out of these 3 numbers, it will not remain a factor of all of them, na? Are you getting that logic? The moment you take the HCF to be greater than any out of these numbers, it will not remain a factor of all of them. So the highest value of the factors of any number of numbers is equal to the smallest out of them. Is that clear? Now what about LCM? What is the meaning of LCM? See this thing. For example, I am taking 15. What are the multiples of 15? 15, 30, 45 and so on. Yes or no? So the smallest multiple, LCM is what? Multiple, least common multiple. So the smallest multiple of a number is equal to the number itself or not? Are you getting my point? The smallest multiple of a number is equal to that number itself. Otherwise, all the multiples of that number are greater than that number. Am I right or not? Is that clear or not? Simple logic. No, we cannot write every time. I'm saying that is the possibility. I'm talking about the possibility, Somaya. We cannot directly say that HCF is equal to the smallest of the numbers. It will not happen every time. It is happening over here only. You got my point? So LCM of multiple of any number, the smallest value of the multiple of a number is equal to the number itself. So if you are finding the LCM of any numbers, for example, you are finding the LCM of 6, 72 and 120. So the smallest possibility for the LCM of these numbers will be 120 or not? Are you getting that? The smallest possibility for the LCM of these numbers will be 120 na? Because it is the least common multiple. So it has to be at least the multiple of all of them. Can the LCM of these numbers smaller than 120? Is it possible? Are you getting that now, Srishti? It is not possible. The LCM of these numbers can never be smaller than 120. Otherwise, how will it be the LCM of 120, multiple of 120? Tell me. Any number smaller than 120 cannot be multiple of 120. So if you are taking, suppose these numbers, the minimum value of the LCM is equal to the greatest value over here. The minimum value of the LCM is equal to the greatest number given in the question over there. I hope that is clear. So that is the logic for HCF and LCM. I hope that is clear. Now understand one thing logically. If you are finding HCF of these numbers, so HCF of these numbers is a factor of all of them. Hi Akshay. HCF of these numbers is a factor of all of them. That is clear. Now LCM of these numbers is a multiple of all of them. Am I right? HCF of these numbers is a factor of all of them, and HCF of these numbers is a multiple of all of them. So can I not say that LCM is a multiple of the HCF? LCM is a multiple of the HCF or not? Am I right? Every time it will happen. Use your mind na. So every time LCM is a multiple of HCF. Multiple of HCF. That will happen every time. LCM is a multiple of HCF. Yeah, that is the same thing, Joshita. Whether you say LCM is a multiple of HCF or you say HCF is a factor of LCM, it is the same thing or not? Or you can alternatively say like this, or HCF is a factor of LCM. It is the same thing, right? Factor of LCM. So HCF is every time a multiple of HCF is every time a factor of LCM, or you can say LCM is a multiple of HCF. It is the same thing. I hope it is clear to every student in the class. Just confirm that once in the chat so that we can move on further. So many a times they give MCQs, objective questions on the basis of these concepts as well. Many a time they do that. Okay, let's move on. So do this one. If P is a prime number, then LCM of P, P square and P cube will be what? Tell the answer quickly. If you understand the concept of LCM, you can see and tell the answer. What is the LCM there? Correct, very good. That will be P cube. Why it is P cube? See, understand one thing. This is a prime number. P is a prime number. For example, you take 2 and then you take 2 square and then you take 2 cube. So basically 2, 4 and 8. What will be their LCM? LCM will be 8, na? Am I right? No, one more logic I will tell. If you don't understand the concept of LCM, then also I will use one logic. Wait. if I'm finding the LCM of these numbers, what I'm actually doing, see to what I'm saying. What is the table of the first number? 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8, correct? What is the table of this? 4 1s are 4, 4 2s are 8, 4 2s are 8, 4 3s are 12, 4 4s are 16. Oh, sorry, that is not 14. That is 16. What is the table of 8? 8 1s are 8, 8 2 is 16, 8 3 24, 8 4s are 32. This is the table. This is the table of these numbers or not? Now, what is the meaning of LCM? It is the least common multiple. It means the multiple of 2, 4 and 8, which is the smallest and common to all of them. So, the smallest common multiple is 8 or not? Tell me. Are you getting that logic or not? So, that is the meaning of LCM actually. Is that clear? Is that clear or not? That's how you think LCM in your mind. Least common multiple. Now, many a times you must have seen people finding LCM like this because they understand the concept of LCM. Many students don't know that, Joshita. I'm being honest about that. Therefore, I'm explaining this. For example, suppose I'm asking what is the LCM of 15, 20, 60, 15, 20 and suppose okay, and 60. What is the LCM of them? Just see and tell that. No. It is not like that. Oh my God. No, Srishti. They are not prime numbers. When did I say that? It is happening in case of prime numbers. P is a prime number there, na? 55, if you will say, is 55 a multiple of 15, Srishti? Is 55 a multiple of 45? No. You see, over here, if you will write table of 15, think in your mind. 15 1s are 15, 2s are 30, 2s are 45, 4s are 60. What is the table of this? 21s are 20, 40, 60. What is the table? And suppose I'm writing 80 as well. What is the table of 60, 120, 180, 240? What is the smallest common value? Tell me. Smallest common value is 60 or not? You got that, Srishti? So that's how you think LCM. So for many numbers, you can think, no, that is 60, Joshita. How can it be 120, Joshita? 15 4s are 60, 24s are 23s are 60, and 61s are 60. So 60 will be the LCM. Least common multiple, na? How can it be 120? Tell me. You see, haven't you done the mistake? Although you were saying that it's fifth standard logic. You got my point? So every time you don't have to find LCM by doing this. If you are doing this thing, you are wasting time. Many students do that in grade 10 as well, like this. 2, 15, 10, 30, and then they will keep on doing that. You got that? It will take too much of time. Don't do like this. Most of the times, you can find LCM orally. You got my point? Because it is about saving your time as well. It's not just about getting the answer correct. It's about getting it on time as well. Nobody is going to wait for you for hours in the examination. I hope it is clear. So that is the meaning of LCM. You must understand, and I'm 100% sure that many students don't understand that thing. They just know how to find the LCM, but they don't know what is LCM. Only Hindi Srishti is not possible. देखो चलो एक one sentence, guys, let me speak in Hindi for 1 or 2 minutes because some students will get it. देखो सृष्टि, LCM का मतलब क्या होता है? सबसे छोटा कॉमन मल्टीपल. जैसे तुमसे बोला गया 15, 20 और 60 का LCM निकालो, तो इसका मतलब क्या हुआ कि तुम 15 का टेबल सोचो. 15 का टेबल ये होगा, 20 का टेबल ये होगा और 60 का टेबल ये होगा. तो सबसे छोटा कॉमन वैल्यू कौन सा है? 60 है या नहीं है सबसे छोटा कॉमन वैल्यू? तो इसका मतलब 60 LCM होगा. इसका मतलब है ना लीस्ट कॉमन मल्टीपल, यानी सबसे छोटा कॉमन मल्टीपल. आर यू गेटिंग दैट लॉजिक नाउ सृष्टि? क्लियर है? आई होप दैट इज क्लियर नाउ. चलो, now can you tell me what is the HCF of these numbers? HCF of 15, 20 and 60. Highest common factor, or wait, let me change the values. Don't do like this because I want to explain one different thing. Suppose I have got Fine. What is the HCF of these numbers? Tell me. किसी भी टाइप का नंबर हो, तुम सोचना है इसी तरीके से जैसा मैंने समझाया अभी, है ना। नंबर कुछ भी हो, प्राइम हो या ना हो, उससे मतलब थोड़ी होता है। सोचना ऐसे ही है, याद मत करो। 5 नहीं होगा, 15 होगा। देखो कैसे, अभी बता रहा हूं, आई एम एक्सप्लेनिंग दैट। HCF का मतलब है हाईएस्ट कॉमन फैक्टर। व्हाट इज द मीनिंग ऑफ दैट? हाईएस्ट common factor. It means a factor which is common to all of them and it is the highest. Are you getting my point? So what is the highest value which is a factor of all of them? 5 is a factor of all of them, Srishti, but that is not highest. Are you getting my point, Srishti? 5 is a common factor, but it is not the highest common factor. 15 is the highest common factor. You see, 15 3s are 45, 15 4s are 60, 15 1s are 15. So 15 is the highest common factor. Are you getting that point? How we are able to think that thing? है ना, हाईएस्ट होना चाहिए, कॉमन होना चाहिए और फैक्टर होना चाहिए, तीनों का. So that is the meaning of HCF. इनका एलसीएम विल बी, एलसीएम देखो इसका 60 होगा, नहीं 60 नहीं होगा, सॉरी. एलसीएम मैं तुम्हें बता रहा हूं, सुनो. 45 2s are 90 and 90, 180 एलसीएम होगा इनका. सृष्टि 180 एलसीएम होगा, निकाल कर देखो. लोएस्ट कॉमन फैक्टर 1. हाँ, nobody is going to ask that thing. हर्षन, लोएस्ट कॉमन फैक्टर तो 1 होगा ही ना भाई. अरे यार, तुम कितने भी नंबर ले लो तो लोएस्ट कॉमन फैक्टर तो 1 ही होगा ना. सोच के देखो ना, कितने भी नंबर ले लो तो लोएस्ट कॉमन फैक्टर तो 1 ही होगा. अच्छा एक बात बताओ, सुनो, मैं अगर तुमसे हाईएस्ट कॉमन मल्टीपल पूछूं, बता पाओगे? हाईएस्ट कॉमन मल्टीपल निकालना पॉसिबल है क्या? If I'm asking what is the highest common multiple, is it possible? बोलो. पॉसिबल ही नहीं है. तुम हाईएस्ट कॉमन मल्टीपल तो निकाल ही नहीं सकते ना भाई. हाँ, वो पॉसिबल नहीं है, समझ रहे हो ना. तो वो तुमसे कोई पूछेगा ही नहीं. तो उसी तरीके से हर्षन, नोबडी विल आस्क लोएस्ट कॉमन फैक्टर. समझ रहे हो ना. तो जो पॉसिबल है, जिसमें दिमाग लगता है, वो पूछा जाता है ना, उसका जरूरत पड़ेगा. आई होप इट इज क्लियर टू यू. सो सृष्टि देखो, रीड द टेबल ना. 15 4s are 60, तो ये तो ऑलरेडी इसका मल्टीपल है ही. 60 तो ऑलरेडी 15 का मल्टीपल है, उसमें कुछ करना ही नहीं है तुम्हें. अब देखना है कि इसका कौन सा मल्टीपल है जो इनके मल्टीपल्स में मैच करे. तो 45 2s are 90 होगा, फिर 45 3s are 135 हो जाएगा, 45 4s are 180 होगा. तो 180 पहला ऐसा नंबर है जो इन तीनों के टेबल में आएगा. बताओ, कॉमन. समझ गए सृष्टि? 180 पहला ऐसा नंबर है जो इन तीनों के टेबल में आएगा साइमल्टेनियसली. तो इन तीनों का अगर एलसीएम निकालते हो तो एलसीएम 180 ही होगा. करके देखो. इज दैट क्लियर? चलो ठीक है. Now can you tell me what about this question? The least number that is divisible by all of the numbers from 1 to 10 both inclusive is what? Now this is one of the standard questions. You must remember the answer to this question as well. ये एक standard question है, आपको इसका आंसर याद होना चाहिए. Lowest, नहीं sir, I'm not getting that, सृष्टि. हाँ, this is one of the standard questions you'll get everywhere. So better if you remember the answer, then it is okay. Correct, that is 25 20, that is correct. So you have to find the LCM of numbers from 1 to 10. So you see, 1 you don't need to write, 2 is 2, 3, 4 is 2 square, 5 is 5, 6 is 2 into 3, 7 is 7, 8 is 2 cube, 9 is 3 square, 10 is 2 into 5. Correct? Now if I will find the LCM, If I will find LCM from 1, 2 up till 10, what is the LCM? So first thing is it is LCM. So you have to take all the prime factors involved. So what are the prime factors? 2, 3, 5, 7. These are the prime factors involved. Now what is the highest power of each of the prime factors? Highest power of 2 is 3 over there. Highest power of 3 is 2 over there. And 5 is, highest power of 5 is 1 only, highest power of 7 is 1. So this is the LCM. This is 8 9s are 72 into 7 5s are 35. Just multiply and check it, what will you get? Just multiply, you will get 2520 because I remember the answer. Is it clear? No, it's not like that. Yeah, I have done that, obviously math. Is it clear up till here? So 2520 is the LCM. Chalo. Now what about this? If A and B are two positive integers, this is a previous year question of CBSE only, such that A is this, B is this, where P and Q are prime numbers. If HCF is this, LCM is this, then you have to find the value of this number, value of this thing. I guess it is sample paper question. I don't exactly remember. Yeah, it is sample paper question of last or second last year, I guess. So over here you see, if you will find LCM of these numbers, it is already given that P and Q are prime numbers. So LCM will be what? You have to take all the prime factors. So P and Q will be there. Now you have to take the highest power of P, na? That's how you find LCM. So 3 will come. Okay, that is HCF first. That is HCF first. So you have to take the smallest power. So 2 will come. And then you have got Q raised to the power 4, Q raised to the power 3. So 3 will come. And in LCM also, you have to take all the prime factors involved, and then you have to take the highest power. So you have to take 3, and in case of Q, you have to take 4. Is that clear? Exactly, 35 is the correct answer. So you see, if you compare these two, M is 2, N is 3 or not. So that will be 2 plus 3. That is 2 plus 3. And if you compare these two, R is 3, S is 4. So 3 plus 4. So that is nothing but 5 into 7. That is 35. Is it clear? That is the answer. Sir, for the if you will exclude 1, then nothing will happen, Joshita. Just use your mind, na? If you exclude 1, no problem in that. And even if you will exclude 10, then also no problem. What does it mean? That it means if you will take LCM from 2, 3 up till 9, then also you will get 25, 20. Is it clear, Joshita? Nothing will happen, na? Just forget this thing. Just forget this. Then also you will get the same LCM or not. Yes. Okay, now you see this is also one of the important questions. This is also like you will get this question in previous year and in NCERT exemplar and in like every type of book you will get this question. Sum of two numbers is this and their HCF is this. You have to find the number of such pairs. Can you tell the answer? Obviously, it provides Nihal. Obviously, Infinity Learn provides coaching for JEE. And NEET as well. Okay, let's see that, RN. Oh, that's good, Nihal. And I hope you did well in your boards. So you see, if the HCF is this, suppose the HCF is this, so can we assume the numbers to be like this, 33x and 33y? Can we assume where x and y are co-primes? Can we do that? Co-prime means what? Two numbers are co-prime, it means their HCF is equal to 1. Two numbers are co-prime, it means their HCF is equal to 1. You got that logic? If it is written that two numbers are co-primes, it means their HCF is 1. Co-primes, or you can say relatively prime. Relatively prime. Two numbers whose HCF is 1, they are known as co-prime numbers or relatively prime numbers. So see, if x and y are relatively prime, the HCF of x and y is 1, then automatically the HCF of these two will be 33 or not. Use your mind. Then automatically the HCF of these two numbers will be 33, correct? Now it is given that sum of the numbers is 528. So can we not say that 33x plus 33y, that is equal to 528 over here, correct? So from here you can find x plus y. If you take 33 as common, so you'll get 528 upon 33. So 11 3s are 33, 11 4s are 44, 11 8s are 88. So therefore you are getting x plus y to be equal to 16. So you want two such co-prime numbers whose sum is 16. You got that? Oh, that's good, Nihal. I guess it is correct, RN. So you want two such numbers whose HCF is 1 and sum is 16. How can we judge those numbers? See this thing. You want sum to be 16. So suppose first one is 1 and second one is 15. Can we say like this? Now increase this by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. And decrease this by 1. So this will be 14, 13, 12, 11, 10, 9, 8, 7. Is that clear? Now you see over here, suppose I'm again increasing 10 and then this will be 6. So you see, whether you take 7, 9 or 9, 7, it is same or not? Because order does not matter over here. Am I right? Order does not matter, na? Whether you say x plus y or y plus x, no problem in that. So it means this thing you will not take. Similarly, this thing you will not take, and then you will not take others after it. Now you see, these are co-prime numbers or not? The HCF of 1 and 15 will be 1 only. These are not co-prime. The HCF of 2 and 14 is not 1. These are co-prime. These are not co-prime. These are co-prime. These are not co-prime. Co-prime, not co-prime. So it means how many pairs are possible? First, second, third, fourth. 4 unique pairs are possible. So 4 is the answer. That is correct, RN. Is it clear, guys? This is a CBSE question. This is a previous year question and you will get in NCERT exemplar. And I guess in, I don't exactly remember, but in sample paper also you will get this. Is it clear to every student in this session? Just confirm that once. So 4 unique pairs are possible. Okay. Oh, that's good, RN. Now you see over here, find the HCF and LCM of these numbers and hence verify that LCM into HCF is equal to product of two numbers. For any two numbers, the product of their HCF and LCM. Okay, Aaron. The product of two numbers, because see, Joshita, if you assume x and y to be co-primes, then HCF of x and y is 1, then only the HCF of 33x and 33y will be 33 or not. Tell me. Joshita, if you will not take x and y to be co-primes, how can you assume that HCF of these two numbers is 33? Tell me. You cannot assume like that, yes or no? I hope that is clear, Joshita. Okay. Now see, for any two numbers, product of their HCF and LCM will be equal to product of the numbers itself. So that you can verify. For example, let us find HCF and LCM of these numbers. What is the prime factorization of 510? 2 into 3 into 5 into 7. This is the prime factorization. Now what is the prime factorization of 92? 92 is what? 46 into 2, right? So it is 2 square into 23. Is that correct? Yes. Is that correct up till here? Yes. Now, what is the product of these numbers? Tell me. If you will find in exponential form, wait. If you will find in the exponential form, what is the product of these numbers? It will be 2 into 2 square, that is 2 cube, then 3 will come, then 5 will come, then 17 will come, then 23 will come. That is the product of these numbers, correct? Now what is their HCF? HCF is the highest common factor. So common factor is 2 only. 2 is the only common factor. So 2 will come and then lowest power of 2 will come. So basically 2 is their HCF. Correct or not? And what is their LCM? LCM means you have to take all the prime factors involved in both the numbers. So 2 will come, 3 will come, 5 will come, 17 will come, 23 will come, right? And then you have to take the highest power of each prime factor. So highest power of 2 is square, 2 square, 3 is one time only, all of them are one time. So this is the LCM. Now what is the product of HCF and LCM over here? What is the product of HCF and LCM? That is the product of these two. So 2 into 2 square is 2 cube. 3 will come as it is 5, 17, 23. So you see, are we getting that product of numbers is equal to product of HCF and LCM? Are we getting that? Then also you can use the same method. Highest power of 2 is 2 cube. Okay, that is 2 cube. Wait. No, that is not 2 cube. You just have to see the numbers. Joshita, see the numbers. You are seeing this, I guess. See the numbers, na Joshita. You are seeing the product of numbers actually. So you will see that product of numbers is coming out to be equal to the product of their HCF and LCM. Is it clear, guys? Same method will be used, Srishti. The method will not change. Okay, are you saying about 3 numbers? For 3 numbers, this logic, this method will not work. For 3 numbers, okay. For 3 numbers, product of 3 numbers is not equal to product of their HCF and LCM. There is a different thing for it. For 3 numbers, product of HCF and LCM is not equal to the product of numbers. There is a different thing. Maybe I'll take it in the next class. Okay. Is it clear up till here, guys? Okay. So try doing this small question. What about this? HCF of 2 numbers is this, LCM is this. You have to find the value of A. It's a small question. Tell me the answer. So product of two numbers is equal to the product of their HCF and LCM. So the numbers are A and 8 over here, and their HCF is 4 and LCM is 24. Hello Sandeep, welcome to this session. So let's see that. So product of numbers will be equal to the product of their HCF and LCM. So over here 8 3s are 24. So A will be equal to 4 3s are 12. That is the answer. Correct. Is it clear? It's a 1 mark question, a very simple objective question. I hope it is clear. Okay. So try doing this one. Product of HCF and LCM of the smallest prime number and the smallest composite number. Smallest prime number and smallest composite number. So what is the smallest prime number? Smallest prime number is 2 and smallest composite number is 4. So what is the product of the numbers? You don't have to find the HCF and LCM, Joshita, because product of numbers is equal, product of LCM and HCF will be equal to the product of numbers itself. Na? We have seen that. So that will be 8. Is it clear? LCM is not 8, Joshita. LCM is 4 only. LCM of 2 and 4 is 4, right? Is it clear? Okay. Now do this one as well. If the product of two numbers is this and their HCF is this, then their LCM is this. Now, second option, reason is HCF is always a factor of LCM. Which option is correct over here? Tell me. LCM will be 4 and HCF will be 2. Srishti, LCM of 2 and 4 will be 4 and HCF of 2 and 4 will be 2. So their product will be 4 into 2, that is 8. Now you see, product of two numbers is this. Product of two numbers is equal to their HCF multiplied by LCM. Correct? HCF multiplied by LCM. So LCM will be what over here? 5780 upon 17. 17 3s are 51, 40. So that will be 340. So therefore, you see, assertion is correct. Reason is also correct. I have explained this in today's class that HCF is a factor of LCM. But you see, the reason is not the correct explanation of assertion. Is it correct? No. The reason is not the correct explanation of assertion, although both these statements are true. So I will say that option B is correct. Both assertion and reason are true, but reason is not the correct explanation of assertion. Correct explanation will be this, that product of two numbers is equal to the product of their HCF and LCM. Is it clear? So option 2 is correct, I would say. Is it clear to every student over here? Please confirm that once. Okay. So that's all we needed to do in this class, guys. Don't forget to like, share and subscribe to the Infinity Learn class 9 and 10 YouTube channel. And also don't forget to subscribe to the Telegram channel as well, because the schedule of the classes, they are shared on the Telegram channel and you will get reminders for sessions as well. And don't forget to press the bell icon because you will get reminders, although the classes are defined for the next 1 or 2 days in advance. Okay. So in the next class, we'll talk about irrational numbers and proofs of irrationality. So that's all we needed to do, guys. I'm Misbah, your maths educator. We'll meet in the next session. Bye-bye. Take care, everybody.